Hi guys, I have a simple example here of how to set bit fields and use bit fields in your controls. So, or in your just class, whatever. And here is my control here called my control. And I've defined an enumeration called my flags. And I've given it the attribute flags so that it can be treated as a bit field. You use the term bit fields with enums and whatnot, and bit masks for imagery. So I've declared a member of my flags and then a property to access that member. And when we set the my flags, we want to test each bit to see if they've been set. And I do that using bitwise and. And if you're not familiar with bitwise and or any bitwise operations, then you're out of luck because I'm not going to explain that in this video. Okay, so I'm using a none flag right here. That just makes your code more elegant, more easy to read. A lot of people do this with their bit fields. It's not necessary though, because you can just assign 0 to your bit fields if you want to clear them. It's just a simple way to clear the fields. You never want to add your bits together with this none flag. That's just going to be a shenanigan. It's basically just for direct assignment to clear your bits. So here I'm testing to see if my my flags is equal to none. If it is, then return, because that means no bits are set. And after that, I'm testing individual bits otherwise. So 1 is going to look like 001 in the bit field, and if it is set, then we're just going to write to the output window. And then 2, flag 2, which is assigned integer 2, is going to look like 010 in the bit field. We're going to do the same thing. And 3 is going to look like 100. Okay, and down in form 1, we're assigning flag 3 to my flag. So I'm going to start it up. It says flag 3 set, good. And we can assign more than one bit at a time, so flag 1 and flag 3 at the same time. So we got flag 1 and flag 3 set. We're going to assign none to see what happens. Flag 1 and flag 3 set, so it doesn't really do anything. And then it'll say no flag set if we properly assign none to it. And we can assign 0 to it and get rid of the none flag. We're going to completely remove the none flag. Oops. Test for 0. I'll say no flag set like I did before, so that's just an illustration of how we don't need that clear flag in there. It's not necessary. So here's the thing. I don't know why, but you need to start at 1 if you want to have your bits properly analyzed without a clear flag. So if you don't start it at 1, if you leave it blank or have something like this, your flags will not be properly analyzed, so it's not going to look like this anymore, I don't think. Let's take a look at this. It'll just say no flag set like it did now. Get rid of this. So it says flag 1 is set. That's flag 1. Hold on. I need to make my illustration here. So we're going to set flag 3. Okay, we're setting flag 3, and we're starting at 0, and then 1, and then 2. So this is going to be 0, and that's going to be 1, and that's going to be 2 is that. It's going to look like that. So we're really only going to have 2 bits to set. and I'll say flag 1 and flag 3 is set, and I've only set the third flag. So just remember, don't start at 0 if you want all of your enumeration flags to be set, or to be able to be added together.